Welcome to this third screencast on GUI programming. We're going to be talking about some basic Java Swing components and how to lay out the components to create interesting GUIs. So basically we're going to talk about basic components. Standard Swing components are subclasses of JComponent, which is a subclass of Java AWT component. So they have a bunch of methods that are very useful that allow you to manipulate each and every one of these components. And the first set is get width and get height. So we can find out or ask the component how big it is on the screen in pixels. So what's the width in pixels? What's the height in pixels? Very useful for trying to lay out your component. For example, your panel, maybe you want to make things 1/3, 1/3, 1/3 or something like that. You can get the width and divide by 3, get the height and divide by 3, something like that. We have the concept of enabled. So is it useful? Can the user interact with this component? For example, a button or a checkbox or a text field or other kinds of things. If it's not enabled, so set enabled to false, it gets grayed out and the user is not able to interact with that particular component. We can set them visible, so we could hide or show them depending on the state of the program or what the GUI is. Maybe you don't want a button even visible, and then later on you pop it up, making it visible. We can set the font for any text in that component. So some components, for example, like buttons or labels, have text. So we can set the font, we can change the font. We also have the concept of background and foreground color. So you could set the background color, we could set the foreground color. Foreground color is used generally for drawing things like the labels or the text, maybe some border type things. The background is what the background of the background color of the component is. Set opaque says that we want to actually draw in the entire background of this particular component. Generally, the only components not opaque is a label, because we don't want the background of the label to override the things behind it, and you sort of want that to be transparent. Most other components are opaque. Naturally, you can make them not opaque by setting that to false. You can assign a tooltip to a component, so when the user moves their mouse over the top of the component and lets it rest there, a tooltip or a little text will pop up. You can set the string there, so maybe you can give a little help hint by setting the string. And then you can set its preferred size, which is saying, I want, when Java does the layout of these components, we'll talk about that later, you can say, I want to be so many pixels wide and so many pixels high. And Java will do its best to accommodate that when the user resizes the window. However, your preferred size may actually have to be adjusted. So those are some of the common methods on components, and they're available to all the components we're going to talk about next. So the first component we're going to talk about is the J button, which is just a simple push button. User can click it with their mouse, they could get the focus, hit enter, which will cause it to click. So to create a button, a J button, we just instantiate the variable and we say new J button, and then we supply a string, which is going to be the label inside the button. So that's going to be the text that the button has. It can be very long, which will make a long button, or it can be short like this and go. When the user clicks, or programmatically when the button is clicked, buttons create action events. And so remember about the event mechanism. So buttons create action events. Action events have there's a couple other methods, but these are two most useful. Is you can get the action command, which is a string, which by default is the text of the button, but you can actually set the action command later, and I'll show you in the next slide how to do that. And the other very important method is get source, which actually returns you the instance of the button that was pressed, or the instance of the component that generated the action event. And in this case, if it's a button, it will be the instance of the button that was pressed. To handle action events, we write action listeners. The action listener has one method, action performed, that takes an action event. In that method, you would decide, which component created the event, and then what we want to do when that component is activated. For example, what do we want to do when the go button is pressed? We might want to start something. And of course, in all eventing, we need to actually register the listener to the particular button or item that we're interested in. So we can say stop go button, add action listener with the listener that we created. And therefore, whenever the button is stop go button is pressed, our listener's action perform method will be run with the action event. So we can do all those kinds of things. Simple action events are generated, we handle them with listeners, we register them. Some other useful methods on JButton. You could set the text of the button. So maybe, for example, in that action listener, once you press go, we want to change the button so that it will now say stop. So we would, in the action listener, say set the text to stop. We can also go at any point and change the action command to a string. That might be useful in this case where our label is switching back and forth between go and stop. Maybe we want an action command that we can use in our action listener to make a decision on which button was pressed. We can also enable it, and as I said earlier, when you set enable to false, the button gets grayed out and is no longer clickable by the user. And lastly, a very useful thing is we can actually, in your program, click the button without the user clicking it. So you can call do click, which will create the action event as if the user clicked it, and then the listener will execute. So you can programmatically click your buttons. So you can write a program that clicks buttons in a GUI without the user having to do anything. Very powerful concept. The next component is the JLabel. It's probably the simplest component that there is. It's basically a line of text in your GUI. That's it. So example, you create it with JLabel message equals new JLabel hello world. And you can see that's a bunch of text that is displayed in the panel when you add it to a panel or in the place. The example below it is we're going to create 3 messages. We can say whether it's left justified, it's in the center, or right justified by adding the left, the right, or the center. And then we can set its foreground, we set its background, we set its font, and we had to set opaque true because in general labels background is not rendered because they're not opaque, they're transparent. So by setting it opaque and by setting the background color to black, you can see that the second message is red on black. If we didn't set it opaque, it would be red on the background gray. So you can change your labels. Labels have the same, you can set their text just like you can set the button's text. So you can actually change your label while you're in your program, and this is a really nice way of doing things like, oh, it's player 1's turn or it's player 2's turn. You have the label, and then as the program goes through, you can change the label to indicate what the current state of the program is. The next type of component is a checkbox, just JCheck box. It allows users to turn things, check them or uncheck them. The 2 states, selected and unselected. To create the checkbox, we create a new checkbox and we supply it some text, which is a label next to the checkbox, sort of in this example, show current time. So if the user wants to show the current time, they could click the thing and you would get an action event, just like you do sort of the buttons, and then you can check the status of the component by using get source on the action event, and then you can say get selected, which will return true or false if it is selected. And again, similarly, you can do click, so you can programmatically change the state of your checkbox by just clicking it programmatically. So these are nice optional tools for allowing the user to choose some choices. Next one is allowing the user to have editable text, so that not just a label, which is not editable, the user cannot change labels, but have some text in a field that allows the user to edit it, change it. It's a great way of getting information from the user, maybe what is your name, and they can enter their name into the text field. a text field, JText field, is just a single line of text. You create it with the constructor JText field. You supply a default string if you want to, or you can just say not a string, and then the number of columns that you want this text field, how wide it is, and then that will create a text field. A text area is a multiple line text editor or error entry thing, and so you supply a default text, the number of rows you want and the number of columns, and then that will produce a multi-line editable. You can make them read-only by setting editable to false, so then that doesn't allow the user to change the text in the text area, so it becomes sort of like a label. And you can get what they edited or what the text content is by calling getText, and that returns a string. If you're talking about the multiple, the text area, there will be new line characters in that string. Those are the /ns or the escaped ends, so that you know where the lines are in that string. Very useful component for getting input from the user. Another thing would be if you have a large text area, they don't have any scrolling built into them. So if you shrink the window, you won't be able to see the entire text area. You'll just see whatever piece is visible. You need to use a JScrollPane, and the example here shows you where we create an input area, and then we create a JScrollPane, and we create it and we supply the input area. And what that does is it wraps the text area with the scroll pane, so that if you shrink the window, you'll get scroll bars horizontally and vertically, so you can move around in your text area, so that you could see all of the text area by scrolling left and right and up and down. Just something you want to think about, that if the user does shrink your windows, you may want to wrap some of your components or your base component, maybe your big outer panel, into a scroll pane, so that the user can scroll around in your window. The next component is a slider, which allows the user to select an integer value in a range. By default, they go from 0 to 100, so if you use the default constructor, JSlider, new JSlider with default constructor, you get a range from 0 to 100. You can define the range you want. You can say paint the ticks, which causes it to draw those vertical lines and giving an indication of where you are in the range. If you set the major tick spacing, that tells the slider where to draw them. So I set them at 25, so it's going to go 0, 25, 50, 75, 100. And then if I say paint labels true, it actually paints the values below the tick marks. If I didn't have that line, we would just have the 5 tick marks. If I didn't set the ticks true, but I did say paint the labels, I wouldn't have the vertical lines. You can get the value of the current value of the slider by saying slider get value, and you can actually programmatically set the value, and when you set the value, the little cursor thing will move to the value you set. And when the user slides the slider, it's not an action event, it's a change event, and we have to use a change listener, which again has one method, and it has a state changed method. It gets this changed event, and again you would probably use the event get source method, and then you can get the value or set the value when the user has changed the slider. And so that's a brief overview of some of the common components that you're going to probably use in your GUIs. There are more out there. They got radio buttons, they've got checkboxes, drop-down selector boxes, a lot of different kinds of Java X Swing components that you could use. But here's just a brief overview of some of them. Take a look at the Java API to get a better understanding of some of the things you can use. There's also some excellent tutorials on how to use the Java components, or the Java Swing components. So the next thing to talk about is laying out the components that we chose on the screen and getting a nice layout. So the idea is that we can put components in different places on the screen, and in this example on the screen we have 2 rows of components, and each row consists of different numbers of components, and they have a different spacing or location on the screen. So in order to do this laying out of the screen, in Java, we have layout managers which control where they place things on the screen. So the layout manager basically is, every container in Java has a method that you can set the layout manager for it, and you can see the hierarchy of JComponent is a container, is a subclass of container, and is a subclass of component. On the first slide we showed how JComponent is a subclass of component, skipped over the container statement, so the Java AWT container class allows you to set the layout manager for any container, so every JComponent can have its own layout manager. And we're only going to talk about 3 basic types of layout managers: the flow layout, the border layout, and the grid layout. There are a couple other ones out there. There's some complicated ones, but these are simple ones and sufficient to actually build up some fairly complicated layouts. So if you see it above here, this could be a grid layout with the blue squares, two rows, 1 column, and then the first blue square could be maybe another grid layout with 1 row and 3 columns, and maybe the bottom one is a border layout with a center and a east, perhaps. So you can use these 3 layouts to get you different behaviors and arrange your components on the screen in a very complicated way. You want to start thinking about, how am I going to draw my boxes? Where do I want my things? What are the layout managers that I'm going to use to build this reasonably complex layout? So let's talk about these one at a time. The first one is a flow layout. All it does is it tries its best to line up the components across the container in a single row. If there isn't enough horizontal room, what it does is it creates another row and flows the components that don't fit into that next row, and by default tries to center each row. So you can see how if I have enough room above and I'm using my flow layout, I can put my 5 buttons all horizontally, but if I shrink the screen, the flow layout will move button 5 down below into a second row, and then it will move button 4 if there's not enough room. And I'll have to increase the size of my window, because if I don't show that second row, like the window keeps the height of the one, I won't see button 4 or 5 because they're on a second row, and until I increase the size of my window, I won't see them, but they're there. So the flow layout is really nice. It does its best to create 1 row, but as things get too narrow, it creates another row, and if it gets even more narrow, eventually it'll create 5 rows with 1 button on each row. Very simple one, very nice layout. The behavior can be annoying when something flows, because then all of a sudden you got 4 buttons with 1 in the center and the bottom, and maybe you didn't resize it, but it's actually a really nice layout. And it is useful because it does allow natural resizing. The next one is the border layout. A little more complicated, but the idea is there's a large central component where most of your stuff happens, and you can have up to 4 smaller components around the border of that center one. And in order to place these components, you tell it the position you want to add the component to. So you'd say container add the component I want to add it, and then you say what position in the border layout I want it to be in. So border layout center, we'll put that component in center. The center expands to fill up the space. It expands horizontally and it expands vertically. North and south, those components will expand horizontally but not vertically. So as you resize the window vertically, north and south don't get taller, the center gets taller. The opposite is true with west and east. As you make the window more horizontal, west and east don't grow in size, center grows in size. West and east stay there, keep their width. So that's an interesting way of managing your layout, and it's very powerful. You can imagine having a flow layout in the north, perhaps, or maybe a flow layout in the west, in the border, or maybe you have a border layout in the east inside of a border layout, something like that. You can do a lot of different ways of building your pieces, and as the window resizes, you know that the east and west are not going to get any wider, but they might get taller. All just things to think about when you're playing out with your border layout or your layouts. And the last layout that we're going to talk about is the simple grid layout. It just makes a grid of equal size rectangles. You tell it how many rows you want and how many columns you want, and it will build the rectangles. When you add things to a container that has a grid layout, they get put in row and then column order. So they get put in like the numbers indicate. So if I add, the first one goes to 1. If I do another add, that will go into slot 2. If I do another add, it goes into slot 3, etc., until I've added 12 things, and so it will fill in the grids, the elements in the grid. When it resizes, they stay equal height, but they get taller and they get wider equally. So it's a nice way of organizing your components if you want them evenly spaced in the thing. And sometimes you do, sometimes you don't. So that's the third component. So you can put these layouts in containers that are inside another container, so you can imagine all sorts of combinations to get the right layout that you want, so that when you draw your GUI, it looks good. The next thing to talk about are borders. Each component can have a border around it, and there are several different kinds of borders, and Java has a border factory to create the borders. You use the factory to create them. The first type is an empty border. It just does space around the component. So in this example, you can see the border factory create empty border. You give it a top, a left, a bottom, and a right, so they can have different mounts of border. And in this case, it's 10 pixels around the top, around the edge, and around the bottom. And it's just space, and that's a nice way of making it so that your components aren't slammed up against the edge of your window. If you put an empty border around them, they'll be sort of padded into your window, and that makes it look a lot better than just having the frame right next to your component. The next one is you can create a line. You supply a color and then a thickness. So in this case, we used the color red and a thickness of 2 pixels. And so you can now highlight your component by just adding a border. You could remove the border or put the border back to empty border. So you can, or you could set the color back to the background. There's all sorts of ways to hide and show the border. So you could set the border, you can set the border to empty border, all that kind of stuff to highlight the particular component you're using. A matte border allows you to set, again, individual top, left, bottom, right, and color. So in this case, we had the top and the left being 2 pixels, the bottom being 5, and the right being 5. And we set it to red, so you can see how it's different sizes. An etched border creates a line, but it looks like it's etched into, it gives a sense of depth to that line, and it sort of looks like an etching. Very nice looking thing. You can do a lowered border, which makes it appear like your component is shrunk into the GUI. You could do a raised border, which makes it look like your component stands out from the GUI. And you can actually add, lastly, a titled border that gives you a title and an etched around the edge, so you can give you a nice sort of hint or maybe a description of the panel or the component or what it is, you know, like maybe username or something, and then you put inside of that, you put your text area or something like that. All of these are very useful. You should play with them. The textbook has a bunch of really good examples that I'm not going to go through in this screencast, but they have some really nice examples of using the layouts to get some nice behavior to their GUIs. So thank you for your attention.